this is a continuation of Lagrange multipliers. So this is a problem number 2. So find the dimensions of the rectangular box without top of maximum capacity whose surface area is 108 square centimeter is given. Find the dimensions of the rectangular box without top of maximum capacity whose surface area is 108 square centimeters is given. So here is we know the length of the box. So length, breadth and height of the box, that is surface area equal to, surface area is xy plus 2yz plus 2zx equal to 108. So surface area is given equal to 108. So next volume is not given, so we can take xyz. So here is the important thing is we can take xyz equal to f and the surface area is g. So y means like they are asking the maximum capacity whose surface area is given. So for previous problem, surface area is a function, then volume is given. Volume is 32 cc, that is volume is given. So that case we can take g is your volume. In this case, the surface area is given 108 square centimeters. We can take that one is g. Which one is given means we can take that one is g. Which one is not given means we can take that one is a functions. Okay, this is an important one. Okay, so that is xy plus 2yz plus 2zx equal to 108. That one is g function. Then volume is xyz, that is equal to f functions. Okay, this is a very important one here. Okay, therefore what is the Lagrange methods multipliers? So f equal to f plus lambda g. What is f? Xyz plus lambda into what is g? Xy plus 2yz plus 2zx minus 108. Okay, so next to find the sufficient conditions, dou f by dou x equal to 0, dou f by dou y equal to 0, dou f by dou z equal to 0. So first with respect to x means, so what is the first value with respect to x means we get yz plus lambda into here is y plus 2z here. So therefore, so yz plus lambda into y plus 2z equal to 0. Similarly, we can find fy xz plus lambda into x plus 2z equal to 0. The third one is with respect to z means xy plus lambda into 2x plus 2y equal to 0. So here is I want yz equal to minus lambda into y plus 2z. Similarly, xz equal to minus lambda into x plus 2z. Then xy equal to minus lambda into 2x plus 2y. So last case you can equating any one side must be equal. For that case, for that one we get the solutions here. So next I can write yz. This one is divided by, so we get y plus 2z. Take the reciprocal here. Okay, so yz, then y plus 2z means take the reciprocal. So y plus 2z divided by yz, that is equal to minus 1 by lambda. Similarly, it is also take the reciprocal. So x plus 2z divided by xz equal to minus 1 by lambda. Then again take the reciprocal. So 2x plus 2y divided by xy equal to minus 1 by lambda. So next is here is I cancelling 1 by 1. So I cancelling y here. So we get 1 by z plus I cancelling z. We get 2 by y equal to minus 1 by lambda. Similarly, here is cancelling x. We get 1 by z plus cancelling z here. We get 2 by x equal to minus 1 by lambda. Then cancelling x, we get 2 by y plus cancelling y, we get 2 by x equal to minus 1 by lambda. Then equating these three equations one by one. First I can take 2 and 3. So can 1 by z plus 2 by y equal to what is 1 minus 1 by lambda. That one is 1 by z plus 2 by x. So cancelling 1 by z and 1 by z. So we get x equal to y. Then again here is same ditto here. Then equating 3 and 4, cancelling 2 by x and 2 by x, then we get y equal to 2z. Then 5 and 6. So equating 5 and 6, we get x equal to y equal to 2z. So next I want the solution for x, y, z. Substitute in the conditions. What is the conditions? xy plus 2yz plus 2zx equal to 108. That is your conditions. So equating everything in terms of z here. So what is x? That is 2z. What is y? That is 2z. Plus 2 into y is 2z, we can z kept as it is, plus 2z we can kept as it is. What is x here? 2z equal to 108. Then adding all the values we get 4z square plus 4z square plus 4z square equal to 108. That means 12z square equal to 108. Z square equal to 108 divided by 12 is 9. Therefore z equal to 3 here. This we can take the only positive value. So z equal to 3 means we can substitute z equal to 3 in the equations. X equal to y equal to 2z here. So z equal to 3 means we get 6, therefore x equal to 6, y equal to 6. What is z? Z equal to 3. Therefore the dimensions box are 6 comma 6 comma 3. So this is another important problem. Okay. The next problem is, this is also very important problem. The temperatures u of x comma y comma z at any point in the space is u equal to 400 xy z square. Find the highest temperatures of this on the surface of the sphere x square plus y square plus z square equal to 1 year. So 1 is missing, that is 1 year. So here is everything is given, so don't find the value for u, value for f and g here. So first I can take u, the first value u is given. First I can take f equal to 400 xy z square. Then condition is the temperature is given. Temperature of the sphere, that is the conditions, g equal to x square plus y square plus z square minus 1. And find the, then substitute in the Lagrange methods of multipliers, f equal to f plus lambda g. So 400 xy z square plus lambda into x square plus y square plus z square minus 1. We can take equation number 1. Then fx equal to 0, fy equal to 0, fz equal to 0. So with respect to x means, so this one is 1, so we get 400 yz square plus 2x into lambda equal to 0. With respect to y means 400 xz square plus 2y lambda equal to 0. The last case with respect to z means we get 800 xyz plus lambda into 2z equal to 0. Then equating your LHS or RHS equal to 0. So here is I can take minus lambda 2x in RHS. Here is also minus lambda 2y from RHS. Then minus lambda 2z from RHS. So next divide by 2x here. So we get 400 yz square divided by 2x equal to minus lambda. Here is also we can take minus 2y from our LHS side. Then minus, that is 2z from RHS side. Then cancelling this value we get 200 yz square divided by x equal to minus lambda. 200 xz square divided by y equal to minus lambda. Then 400 xy equal to minus lambda. So equation number 2, equation number 3 and equation number 4. So using 2 and 3, so cancelling the remaining values we get y square equal to x square. Then 3 and 4 means we get 2y square equal to z square. So 5 and 6. Then equating 5 and 6 here. So what is there? X square. Then what is y square equal to z square by 2. Therefore x square equal to y square. The y square is z square by 2. Then substitute this value from equation number, that is given conditions. So x square plus y square plus z square equal to 1. So substitute the value for, here is everything in terms of z value. What is x square is z square by 2. Then y square is z square by 2. Then z square you can keep as it is equal to 1. And simplifying this one we get z equal to plus or minus 1 by, so that is z equal to plus or minus 1 by root here. Then substitute this value from the given equations, that is everything must be in positive value, z equal to 1 by root 2 whenever squaring here. So substitute this value z square, here is z square means what is z square, we get 1 by 2, either positive or negative. So z square equal to 1 by 2 means we get 1 by 4. Next we can find x square value and y square value. Therefore we get x square equal to 1 by 2, that is 1 by 4. Therefore x square equal to 1 by 4, x equal to plus or minus 1 by 2. Then y square is also 1 by 4, therefore y equal to plus or minus 1 by 2. Therefore your question is find the maximum temperatures. So substitute this value from the given functions u equal to, that is f of x. Therefore 400 xyz square is given. So replace x is 1 by 2, y is 1 by 2, z is 1 by root 2. That is only positive values. Don't take the negative values here. Therefore the answer is 50. The maximum temperature is 50 here. So very important problem. Okay, be careful here. Then these are last problem for these sections. So these are very important 60 mark questions. Find the maximum volume of largest rectangular parallelepiped that can be inscribed in an ellipsoid x square by a square plus y square by b square plus z square by c square equal to 1. The condition, that is function is given, that is u f is given, that is condition is x square by a square plus y square by b square plus z square by c square minus 1 is condition is given. So next to find the functions here. What is the functions? The volume of the rectangle solid means we get 2x 2y 2z. That means volume equal to 2x into 2y into 2z, that is 8xyz equal to f. Okay, already I told the given is a conditions, which one is not given means we can take that one is a functions. That is the main thing here. So which one is not given? Volume is not given. So volume of the rectangular ellipsoid means 2x 2y 2z, that is 8xyz equal to f. Then condition is given, so x square by a square plus y square by b square plus z square by c square equal to 1, that is a g is given. So therefore substitute this value from the Lagrange multiplies f equal to f plus lambda g. What is f here? 8xyz plus lambda into x square by a square plus y square by b square plus z square by c square minus 1. This is equation number 1. Next find fx equal to 0, fy equal to 0, fz equal to 0. So first we can find 1 by 1. So first differentiate with respect to x means we get 8yz plus 2x lambda by a square equal to 0. Then fy means 8xz plus 2y lambda by b square equal to 0. Then fz means 8xy plus 2z lambda by c square equal to 0. That is differentiation of x square is 2x here by a square. We can write that one. Okay. Then equating your LHS equal to RHS form, that is any one side must be equal, everything must be lambda here. So here is I can cancelling lambda, here is I can do in the similar methods, that is some other methods. So here is I can take 8yz equal to minus 2x lambda by a square. Then 8yz divided by, I can take minus 2 lambda from your LHS, the remaining thing is x by a square. Then cancelling this one we get minus 4yz by lambda equal to x by a square. Then multiply x on both sides, therefore we get minus 4xyz divided by lambda equal to x square by a. Similarly here is we can find minus 4xyz by lambda equal to y square by b. Again similarly here is we can multiply the z form, so minus 4xyz by lambda equal to z square by c. That is here is we can multiply y on both sides, here is we can multiply z on both sides. So here is we can take LHS, every LHS must be in equal form, therefore equating 2 and 3 and 3 and 4. So we get x square by a square equal to y square by b square equal to z square by c square. So these are given. Okay. So next we have to find the value for x, y, z. So substitute this value from the given equations. So what is x square by a square plus y square by b square plus z square by c square equal to 1? That is the conditions. We can substitute the value from the given conditions. We get. So what is the value where x square by a square you can write as it is. What is y square by b square? That is nothing but x square by a square. Now what is z square by c square? That is nothing but x square by a square equal to 1. So adding these three values we get 3x square by a square equal to 1. Therefore x square equal to a square by 3. That implies x equal to a by root 3. Then similarly we can find y equal to b by root 3. Then z equal to c by root 3. Therefore this is the extreme point for the maximum condition is a by root 3, b by root 3, c by root 3. So next I want maximum value. Substitute this one from given equations, that is given functions. V equal to 8, that is 8 times of x, y, z. We can replace x value, y value, z value. We get 8abc divided by 3 root 3. So this is a very very important problem and also important concept here. If any doubt means we can ask in the Moodle class. Okay, thank you. We will continue the next sessions.